Hi folks, so this is the toaster oven that I got from Walmart that I'm planning on converting into a reflow oven. Um, so this is actually, it was for $40 on their website, but when I actually went to the store, they did not have it in stock, and I ended up buying the floor model, which um, Walmart apparently had discontinued this product. So it's actually a $40 oven that I got for $20. So pretty good deal, I would say. And this is exactly what I was looking for. Primarily because I've been reading a lot about these ovens online and what people have been using to convert for reflow purposes. And something they mentioned were the quartz elements, which are these white. I don't know if you can see that, but they're like got a milky white look to them. And also, it's I think a 1500-watt oven that has two elements at the top and two at the bottom, and it's also a convection oven. So it has a fan in there, which is pretty cool. And I thought it would be good to have one with a fan so that there's equal heat distribution when the boards are baking. So anyway, I'm gonna convert this oven into a reflow oven using the Controleo, which I bought from Wizoo.com, and I'll be documenting how I convert it. So yeah, stay tuned for that part. So a couple of safety features that I wanted to highlight that I have put into my design. First thing is are these solid state relay covers. I really think they are a great buy for this particular project, primarily because it helps cover these contacts that are on the relay and makes it a bit more safer inside this toaster oven. So yeah, definitely worth investing in these. These are specifically made for this brand of SSR that I'm using. It's a Cridum solid state relay, rated for 240 volts, 125 amps, and on the input side, it's a 3 to 32 volts DC. So yeah, consider these. And the second thing I wanted to that I actually incorporated were these connectors for the posts on the AC side. I wanted to put these in because I wanted to lessen the chances of these wires actually coming loose and basically flopping around inside the metal casing here. So I wanted to add these as well, just as an extra measure to ensure that these wires stay attached to the solid state relay. So I think that's those are two important things to consider, especially with AC voltages in this project. You can also see the paste that I put in there under each of the relays. That's just thermal paste, PC thermal paste. And I'm using this aluminum bracket that I made out of sheet metal. I just basically just got a piece of sheet metal from Home Depot. This aluminum sheet metal. It's like I think like $8 for this piece, and I just fashioned a little bracket for it so that I can mount all of the solid state relays on it. Aluminum's good because it's a very good conductor of heat, and it'd be a good heat sink for the relays. Um, so yeah, just some of the things that I wanted to mention. Anyway, I'll continue putting this together, and I will give a full demo and a walkthrough once I'm done. Also, as a safety feature, you want to get rid of any metal shavings that are inside this compartment, especially while drilling and doing all the modifications. There are shavings, the metal shavings that'll come off and fall into this compartment. So I just thought of a way of removing these filings. So what I did was I just holding this very powerful magnet or a one of these magnets I picked up at Home Depot um, with a needle nose pliers and just basically just run it on the inside of the compartment on the base here, and what it'll do is it'll actually pick up all the metal shavings that were in there. Um, Works pretty well actually, and it managed to pick up quite a lot. So you might want to do this as well, just so that you clean up the inside here before you close up. Um, yep. So I got done making the modifications to my toaster oven for reflow. and this is the final product. Glad that it came out pretty well, actually. So let me just kind of walk you through the modifications that I made. So this is actually a convection toaster oven from Black & Decker that I picked up at Walmart. Its regular price of $40. I got it for like 20. Um, so the modifications that I made was adding the 3 solid state relays, and also adding this wall wart so that I can actually power the reflow controller, which is the Controleo. I'll post the link to the website for this particular controller. I think it's pretty cool. Gentleman who makes it has done a great job um, making the hardware. Yeah, so check it out. It's called the Controleo. But anyway, the modifications that I made were, well, first of all, there are 4 elements inside this particular toaster oven. There are 2 at the bottom and 2 at the top. So what I ended up doing was having one SSR control the top element, one for the bottom, and one for the convection fan that you see here. So that's actually in here, a little vent right there for the convection fan. So the Controleo actually allows you to program the relays depending on how you have it connected. So the modification that I made was basically removing all the control knobs in the front here. Basically just cut out all the wires that control these knobs and rerouted the wiring to the relays. So what I have here is basically, so this is the main hotline coming in that I've spliced and distributed to each of the relays. So one here, and another one over here. And then the other end of that, the relay goes straight in the element for the top one, which comes back around on the other side of um, the oven, and the neutral comes back out here, and that's spliced with this, and then that goes out to the neutral to the wall. Same thing for the bottom. I got a hot right here, which is the other end of the relay, that goes into the bottom element, comes out and goes into the neutral, and again back to the wall. And also for the fan, you can see here there are 2 white wires. That's to the fan right here for the hot side, and the other side goes to the neutral to the wall, which is spliced down here. So all 3 are connected. And on the DC side, as you can see here, I just used a Cat5 Ethernet cable that I just used to distribute or to control, to connect to the controller. And they all have common positives, and the negatives are per channel or per SSR. And then that's actually highlighted pretty well on the Controleo website. I don't know how to hook this thing up. As I mentioned earlier, I have the covers on the solid state relays. And then in here, I have the K-type thermocouple, which actually comes with the Controleo, which is pretty cool. So yeah, I just made a little hole in the toaster oven compartment and just routed that wire out the back and goes into the Controleo. So yeah, so those are basically the modifications that I made. Try to be as cautious as possible. I have a very healthy respect for AC currents and voltages, so always had a fire extinguisher at hand when I was testing this thing. But anyway, I'll hopefully get a chance to run it and show you it reflowing. I actually did a test run of this, and the Controleo worked pretty well, where it went through the whole reflow profile. And I actually had to add some foil to the inside of the insides of the toaster oven because the temperature wasn't climbing as quickly as the controller would have liked. But adding the foil lining definitely made a difference, and it allowed the temperature to be more quickly concentrated inside the toaster oven. There are other alternatives. Again, the Controleo website mentioned something about this gold tape that you can use. It's a high temperature tape that you can basically paste on the the door and on the inside so that it's well insulated. I'll probably be doing that at some point. Which first I just wanted to test it out and see how it goes. So yeah, so that's my toaster oven modification for reflowing. Um, I read a lot of stuff on this. I watched a lot of YouTube videos on these and people doing it. And yeah, without all the videos out there, I probably would not have been able to do this. So because I was always concerned how well this would come out. So we'll see once I reflow my first board how well this thing works. But so far so good. Thanks. So this is a test run of the Controleo. I've turned it on and it's currently in the pre-soak. And as you can see, the temperature is rising and the elements inside are on, along with the convection fan, as you can see. So it's controlling the ramp of the temperature. The three lights in the front indicate each of the elements and the fan. So it's actually toggling um, between the elements to maintain a nice steady rise in temperature instead of a quick ramp. But all of that can be adjusted in the software. I haven't personally tried it, but I believe that capability is there. You can upload a sketch with your own profile. So the maximum temperature that I've set this at is 240 degrees Celsius. So it should hit reflow at some point shortly, and then it'll ramp quickly up to 240. Okay, there you go. So it's hitting the reflow now. And obviously I don't have a board in there, but I'm just doing this as a test run to see it go through the profile. So once it hits a 240, it should enter the cool down phase, which is essentially with the, so now it's holding it there at 240, 250 for about 21 seconds. So this is supposed to be the reflow stage. So it'll hold it there for about 13 more seconds and it'll hit cool down. At this point, just the fan is on, the elements are off. Okay, there you go. So reflow is done. It says to open the door, so help it cool down quicker. So open the door, blast some hot air. So at this point it will go all the way down, and now it's saying okay to remove the boards at about 100 degrees Celsius. So it'll keep going. The fan will stay on until you hit 50 degrees Celsius. So at this point, I guess the fan is just on for cooling purposes.